what I would like to talk about today is structured in a few parts. At first, I will give you some brief information about ICRON as the company and what we do. And then I would like to discuss some background information backed with some statistics about supply chain optimization, and talk about what we mean by decision-centric optimization. And then I will go to the more technical part, where I will be discussing the technical architecture of ICRON and how we integrate with Gurobi and what kind of capabilities we provide with the package. And then I will talk about a specific customer case at Vestel Electronics, for which we have been working together for a long time, and we've been delivering decision-based optimization solutions. Now, ICRON, at ICRON, we work on, we develop a platform that is integrated and intelligent, and for targeting strategic, tactical, and operational decision processes. We have been working on this product for more than 25 years, and we have right now over 100 customers for whom we have delivered over 500 implementations all around the world. And we have 4 offices. We have offices in the Netherlands, Turkey, Malaysia, and Singapore. And our customers are active in a number of areas, including electronics, including aviation MRO, and also glass manufacturing and logistics, etc. So we have a large customer base, and for whom especially we have delivered a large number of optimization-based decision support systems across the globe. Now, some background information about supply chain optimization and why it's a significant problem, and what happens if we can actually, what kind of achievements we can do if we can solve it right. Now, this is some information about a poll that was conducted by Supply Chain Insights, and they asked a number of supply chain executives the question of what are the elements of the business pain that you feel in your supply chain. And there are, of course, a large number of different types of business pains, and they ranked them from the most important to the least important. And the results came up as the most important business pain came up as demand and supply volatility, or dealing with demand and supply volatility. And then the second one that came up with 38% of the respondents responded saying that their most important business pain is cross-functional alignment or lack of cross-functional alignment. And then 37% responded saying that their biggest issue is supply chain visibility or lack of supply chain visibility. And similarly, a significant percentage responded saying that they do not have the right data, or even if they have the data somewhere, they cannot access it when required. And 35% responded saying that the most important pain that they feel is availability of skilled people to do the job, or enabling those people to do their job properly. There are, of course, a number of other pains, including supplier reliability and organizational changes, and executive teams' understanding of the supply chains, and clarity of business strategy and globalization, risk management, etc. But the most important keywords that I see are volatility, demand and supply volatility, alignment, and data, and basically visibility and people to do their job. In a recent report by Gartner, there was also a question asked to supply chain executives, and this time the question was, using advanced analytics, what kind of improvements have you achieved within your organization, within your supply chain? And the usage of advanced analytics includes categories like predictive, prescriptive, machine learning, artificial intelligence, all kinds of advanced analytics. And 73% of the respondents said they were able to improve demand forecast accuracy. 69% said they could improve order lead times, so they could reduce order cycle times, and increase capacity availability, total supply chain reduction, total supply chain cost reduction, and transportation costs specifically were above 60% of the respondents responded with these improvements. And a significant percentage also said that they were able to experience improvement in the customer service and reductions in inventory levels. Now, this means that usage of advanced analytics provides, if done right, it can provide very significant improvements in the underlying supply chain business metrics. But then the question is this easy to do, and why is not everybody doing it? What are the challenges? Now, in the same survey by Supply Chain Insights, that was the question. So what are the most important challenges in building effective supply chain planning processes and using analytics? And one of the most important answers was not having access to the technologies that support the process. And of course, there are different answers, all also relevant. Some of them include understanding and support from the executive team, and planning is fine, but execution of the plan is poor, so that could be a problem in certain areas. And then there is some organizations experience difficulty regarding the lack of clarity of the supply chain strategy. And of course, there are issues like the finance and budget and others. But the most important challenge has been cited by supply chain executives as not having technologies that support the process. And this is where ICRON and Gurobi come in. Now, I'd like to discuss what we mean by decision-centric optimization by talking about the role of planning and optimization in the big picture. Now, on this diagram, if you read the diagram from right to left, eventually all organizations have a business goal. So this could be ensuring profitability or making sure that the organization is the leading party, leading player in the market, etc. So there is an eventual business goal and a small number of eventual business goals. And there is a number of business objectives that support these goals. For instance, one of the objectives could be ensuring that the capacity utilization is about a certain percentage and the cost of transportation is below a certain range, and so on. So there's a number of business objectives, including also customer satisfaction levels are above a certain ratio, etc. So there's a number of business objectives that impact the overall business goal. And where the values of these business objectives come from are basically, they depend on the actions that we take. So you make a certain investment decision today, which will impact the available capacity that you have and your satisfaction levels of the customers. So today's actions are going to, after a certain lead time, they will impact future business objectives and therefore whether the company can attain their business goals or not. But then where do the actions come from? Well, if we take one more step back, we first need to make a decision about something to turn it into the action. And how do you make a decision? Well, all decisions are basically, they have two sides. One of them is the organizational part of the decision. So who makes the decision? How frequently is the decision made? And what kind of approval mechanisms are in place? Based on which information is the decision made, etc. So there is the business process around the decision making. And then the decisions also are made based on certain data and then certain algorithms that are processing the data. So this could be very simple data, like the data on a spreadsheet, and algorithms could be something like a small macro on the Excel or just manual decision-making process. But at the end of the day, there is data that might be very simple or very sophisticated, like real-time data collection using IoT devices, etc. But in a nutshell, I see each decision having two different sides. One of them is the more organizational side, and the other one is the more technology side. And if we dive a little bit deeper into what kind of data exists and how, what kind of algorithms exist, etc., the picture becomes more clear, and it maps with the trends in the technology landscape. Now, recently we have had IoT devices, and we have had the MES systems for a long time, and the data could be in a database or an ERP system, or it could be partly on ERP and partly on spreadsheets, or there's a number of applications that are available through a web service as a web service or REST APIs. But typically the data is not the data that is required to make a decision. It's not all in one place, but it's typically separated over multiple data sources. And when it comes to algorithms, there are different types of algorithms that you can use to make supply chain decisions. And the most significant ones are optimization, heuristics, and machine learning, artificial intelligence type of methods. And in the Gartner report that I was referring to earlier, one of the questions that was asked to supply chain executives was, what kind of advanced analytics methods do you use in your supply chain organization? And 73% answered saying that we use optimization, 44% said we use heuristics, and 50% said we use machine learning or other AI-based methods. And therefore, optimization is used commonly in dealing with supply chain problems. And when it comes to the organization side, the business process itself needs to be somehow defined solidly within the software environment, and the underlying workflow about approvals and storing past information and comparisons are important. And there's always multiple stakeholders that need to either add the data or investigate the results, approve the system, etc. So the system should support multiple users, and there should be a significant, a well-defined collaboration mechanism between those users. And an important functionality in any decision-making environment is scenario capability. So business decisions are made by investigating a number of scenarios. What if we had more demand? What if we had less demand? Or what if one of our suppliers failed to deliver us the required components? What if the number of what ifs is infinite, and it changes depending on the decision context at the time? What if we invested more versus less, etc. And basically, the resulting business metrics and KPIs also need to be part of this entire decision-making environment, and the user interface, the web capabilities, etc. So to make a software product that supports decision-centric optimization, you need both data integration capabilities across different levels, algorithms, different kinds of algorithms, because for certain supply chain problems, optimization works best. For certain decision problems, heuristics work very well, and AI, machine learning, or statistical capabilities are important for other types of problems. And when it comes to the supporting organizational business process structure, there is a number of additional capabilities that are also required, so that right decisions can be made, which can be turned into timely and accurate actions, which eventually will allow the company to reach their business objectives. When it comes to the level of maturity of any decision-making process, I think it's important to identify different aspects. So there is data collection maturity, or how accurately and how quickly the data can be collected. And things like IoT devices or sensors or RFID technologies, those kind of things come into define how mature the data collection process itself is. And then there is the maturity of the data itself. Even if you can collect all kinds of real-time data on certain kinds of data, if the master data on the underlying ERP is not mature enough, then the combination of the transactional and the master data may not be very usable. And even if you have the right amount of data, the right kinds of data, if you don't have the right algorithms to process them, to come up with good solutions for your underlying planning and optimization problems, then that data may not help turn into the right decisions. And even if the technology layer is very mature, if the organization around it is not capable of actually utilizing that technology within the appropriate decision-making process, then even if the technology is very good, then the business results may not be achievable. And even if the right decisions are made, but they cannot be controlled when it comes to the actions, if the process control maturity is not sufficient, then decision-making process may be fine, but then the business objectives may not be achieved. So I think it's important to look into all of these aspects, and at the beginning of any project, any decision-centric optimization analytics kind of project, look at all of them and identify where the organization is across all these dimensions, and then have a plan to improve these as needed. So this would actually be the right way to come up with the business value, instead of just choosing one of them and investing a lot of time and effort on just improving, let's say, data collection maturity. Now, with this background, let's discuss ICRON and Gurobi within this framework, within supply chain and decision-making environment. First, I will talk about the technical architecture of ICRON. Now, ICRON has a number of components, and the most important component is the ICRON server. ICRON server has all the algorithms, optimization models, heuristics, machine learning models, etc. So that's the part which has all the logic and workflow capabilities, etc. And it's accessible by the clients using either a Windows client or a web client. And in many enterprise settings, the data is in a number of different locations. Part of the data is in back office data systems like ERPs or databases, but part of the data is in external data systems, and you need different kinds of integration mechanisms to communicate with these individually. So we have an environment called ICRON Modeler, which actually connects to underlying data, and then you can define how the data is mapped into ICRON systems object model, and what kind of algorithms should be executed, how the data should be validated, etc. And this is how the overall system is composed of a number of different components that we can utilize as needed. And when it comes to using different kinds of algorithms that are best suited for certain kinds of problems, we have a number of calculation engines. And for optimization, we use Gurobi. For analytics, we have integrations with R and Python environments. For scheduling, we have our own scheduling engine, and we have algorithms, a specialized engine for routing and pegging. And especially pegging is very important due to the fact that it can actually enable global visibility across the supply chain. And if the ICRON object model on the server, it has access to information about how the transshipments between multiple facilities are handled and what the production steps are in individual facilities are, and what the demand is, where the demand is across the network. Then the pegging engine can link all transactions, all existing inventories and planned productions and planned shipments with the customer demand satisfaction. So basically, it gives you a full global picture of how the supply chain operations are linked across multiple locations and multiple countries, possibly. Now, the capabilities of these calculation engines are needed to model different kinds of problems. And what we also have is a graphical algorithm environment called GSAMS. And using GSAMS, we can actually combine and utilize these underlying calculation engines to come up with the right algorithms to solve our customers' problems. Now, GSAMS is a visual algorithm modeling environment. It's like a flowchart diagram, but basically each node that you see in this screen, those rectangles, we call them nodes. And each node is a particular processing unit. So there are different kinds of nodes having their individual functionalities. And the link there, each node has a number of inputs and outputs. We call them link points. And the data flows on this algorithm via the relations, which represent data flow. And GSAMS has a number of capabilities. First, it's an it allows for object-oriented modeling. So using classes and algorithms and functions on classes, it's completely object-oriented and supports multiple algorithmic paradigms, including optimization, including scheduling, analytics within the same environment. We can combine predictive and prescriptive analytics. And it also has in-memory parallel computing capabilities to solve problems faster. And optimization itself and Gurobi itself is also embedded, integrated with this environment. We have a number of nodes that are dedicated to modeling and solving an optimization model. And here you can see an example of how an integer programming problem can be defined using ICRON and Gurobi. And the main steps as an algorithm are first creating a Gurobi model and then setting decision variables and then adding constraints and adding one or multiple objective functions and then solving the resulting model. And if the solution is feasible and if it has been optimized, then you can actually accept that solution. Otherwise, you can run infeasibility analysis on the solution. And this is also an object-oriented. It allows for object-oriented algorithmic modeling. And any kind of integer and linear programming problems can be modeled on this. And the models can be debugged. And we also support multi-objectives that was introduced in recent versions of Gurobi. And also capabilities of Gurobi like warm start and infeasibility analysis, they're all usable within ICRON on this graphical environment. And for supply chain, I think Gurobi is a good solution engine, a calculation engine, because its features match quite nicely with a large number of supply chain requirements. For instance, supply chains are dynamic and they have large-scale operations and that need to be optimized quickly. And Gurobi has high performance, and there are multiple business objectives, and Gurobi supports multiple optimization objectives. And there is not necessarily one-to-one correspondence in between. So typically, to achieve one business objective, you need to define multiple optimization objectives. I would say ICRON is more concerned about business objectives, and Gurobi is being a mathematical optimization tool. It's concerned more about the optimization objectives, but I think we have a good match in between. And in supply chain units, rapid what-if analysis, and Gurobi has warm start capabilities. So if you modify only part of the data or add something, just a new product, etc., then Gurobi can utilize existing solution as a starting point so that the subsequent optimization runs are much faster. And business requirements change all the time, and Gurobi has flexible modeling capabilities. You can change your model over time, add constraints, add variables, etc., without modifying the underlying solution algorithm. And sometimes there are conflicting constraints, and Gurobi has infeasibility analysis for us to identify why exactly the problem is infeasible. But sometimes there are small data errors, and it doesn't really have a business impact. It's just a small data that somebody entered wrong. But the problem, mathematically speaking, can become infeasible. But Gurobi has infeasibility relaxation, which pretty much ignores those small infeasibilities and still comes up with a solution that's optimized in a certain sense, that's usable by the business. And sometimes we need quick and good solutions, and Gurobi has a number of good heuristics. But sometimes we deal with problems with high financial impact. So if you're optimizing over a 1.5 year time horizon over a supply chain that contains facilities in 10 different countries, then you're talking about billions of euros in the supply chain value. And there's a significant difference, financial difference between a solution that's good and a solution that's actually optimal. And Gurobi is about optimization. So given enough time, it can actually solve problems to optimality. Now, therefore, Gurobi is a very good choice for us in dealing with supply chain optimization problems. But I would like to remind that Gurobi is for optimization, and there are different kinds of algorithms for solving different kinds of supply chain problems. Sometimes optimization is the best choice. Sometimes other algorithms are the right choices. So I think it's important to complement Gurobi's optimization capabilities with other types of algorithms as we do in GSAMS. Now, when you put the entire package together, this is what the user interface looks like. And on the user interface, we allow for editable charts and editable and data and user customization on the user interface, on report definitions, dashboard definitions, etc., and KPI monitoring capabilities, which are important for business users. And of course, there are multiple users and there are different user roles, and there are all kinds of authorization, authentication capabilities already part of the system. And each user can define their own scenarios. They can actually compare their scenarios and their internal scenarios, and also with they can combine scenarios with other users, compare scenarios, so that they can actually converge to a small number of good scenarios to be taken into account for senior management. And then there are messaging and collaboration capabilities in between the users to support the underlying business process. And when it comes to the more managerial view, you can define dynamic dashboards within ICRON, and includes capabilities like filter and drill down, KPI comparison, similar to BI tools that are available. Now, with this information, I would like to spend the remaining time discussing a particular customer case at Vestel Electronics. Vestel is a group of companies, and they have operations in consumer electronics, household appliance, defense, marketing, etc. And they have over $4 billion revenue. And Vestel Electronics is the biggest company within Vestel Group. They're actually the biggest television LED TV manufacturer in Europe. They have around 20% share in the European market, and their production capability is around 10 million units. And that's roughly 30,000 daily. And television is a heavily customizable product, and the technology is rapidly changing. In the last few years, we also saw the evolution of TVs from plasma, TFT to LCD to LED, and then 3D televisions came up, and then smart TVs, ultra high definition televisions, curved TVs, OLED TVs, etc. In this environment of rapidly changing technology, almost 80% of monthly production in Vestel is for new products, and the entire product portfolio refreshes every 6 months. And Vestel has a number of their own brands, and they also have OEM agreements with leading European and Japanese brands. And in this environment, many of Vestel's competitors try to create a stable operational environment by limiting product variety and increasing order batch size, and putting certain constraints on order acceptance and order fulfillment times. Whereas Vestel's competitive strategy is based on flexibility and responsiveness, and they try to maximize their responsiveness to their customers and also flexibility of meeting customers' demands. And therefore, they have a more dynamic operational environment, and they need to efficiently manage their corresponding operations and supply chain. And they allow for mass customization, so the customers can, even though the production is done at mass scale, it's still customized by the customer. And then order acceptance and order fulfillment times are much smaller than competition, and 37% of the orders are fewer than 200. And if you remember that the total production capacity is around 10 million, this really shines out as a very small number of units for a total large-scale production. And this is what the supply chain looks like. And almost 90% of the purchasing is from Far East, from hundreds of international suppliers acquiring tens of thousands of components. And almost 90% of the sales is to various European countries, to over 400 different customers, several thousand models. And just geographically, you can see that the inbound logistics lead time is significantly larger than outbound logistics lead time. So on the purchasing side, there is on average 90 days of average lead time, whereas on the order fulfillment side, average is about 30 days. So the main challenge is how to manage the lead time difference between procurement and sales. That was one of the things that we dealt with in this project. And if customers were willing to order early, that would not have been a big deal. But this is a graph that shows the difference between realized customer orders versus forecast as a function of time. So if this is the beginning of month T, and we are expecting to sell 100 units, that's the forecast, only 75% of it has been yet realized as customer orders. So remaining 25% is going to have a due date within the current month. And the ratio drops significantly for the next month and then the following month, etc. And for T+3, the ratio is around 5%, which is what you need to know in the procurement lead time. So basically, you need to actually make the right decisions to order the products, the components that you need for T+3 and beyond, without actually knowing anything firm about the realized customer orders. So the system needs to run mainly on forecast, but as new information becomes available when customers order, then the calculations need to be made again and again, and the system should be always kept in an optimal way. So this was one of the main challenges in this particular setting. And Vestel has a sales and operations planning process to deal with this kind of decisions, and the main inputs are from sales and marketing, manufacturing and procurement, and also R&D departments. Now, sales and marketing, manufacturing, procurement, they are parts of pretty much all sales and operations process across the industries that I have seen. But research and development is interesting in this particular case because normally in many industries, R&D is an offline effort. And first R&D develops their product, and then when it's ready to be manufactured at large scale, then that production is made, and sales and marketing and manufacturing and procurement start working with that product. But if you remember the rapid change of technology, we are talking about a planning horizon of at least 4-6 months and beyond, and the entire product portfolio will be different in 6 months' time. So there's a lot of product introduction and engineering changes that will happen in that time. Therefore, R&D is also part of the S&OP planning process. And basically, the S&OP planning process is dealt with the executive management and the senior management with representatives from a number of different business functions to align their constraints and align their preferences and cost structures. Now, we built an optimization model to do this, and the main objective functions are about ensuring customer satisfaction as much as possible, minimizing operational costs like production, procurement, inventory, and there is a number of business preferences that need to be satisfied as much as possible. And the main decision variables are how much do I produce in each period and how many items do I need to purchase in addition to what's currently on the way in each period. And the main constraints are about sales forecast satisfaction, ensuring that customer orders need to be satisfied depending on the customer prioritization. And then manufacturing capacity is a constraint, and critical component availability is also a constraint. And there's also a set of manually created constraints in our decision environment. So basically, the user, the end user, can actually first run the model with the current data, and then investigate the output and add manually using the user interface in a setting similar to an Excel pivot table. They can add manually new constraints and then run optimization again. So this helps them do a lot of what-if analysis over time, and also create additional constraints that were not part of the system when we first designed the system. So this is what the optimization model looks like mathematically. So it's very similar to an aggregate planning model. It has inventory balance constraints and capacity constraints, etc. And then the manually created constraints are the last item at the bottom. So the user can choose whether they want a greater, equal, or less than or equal to type of constraints on the fly. And this is what the system, how the system behaves. And so on the left-hand side, the data, most of the data is coming from ERP. And then ICRON extracts the data from ERP, does the validation and certain transformations. And then the algorithm to solve the optimization model, given the current data, is actually an algorithm like in the middle. And then once the optimization result is available, then it's presented to the user through the user interface, and the user actually either creates a new scenario or modifies certain data or certain constraints and runs the model. And once they're happy with the results, then the results are fed back into the ERP system. And some information about the magnitude of data. And in the system, there are around 10,000 planning materials. These are products that are relevant for long-term planning. And there are around 15,000 processes, and the planning horizon is 6 months and beyond, which translates into an optimization model of 150,000 decision variables and around 200,000 constraints. And the data integration, validation, and transformation time from ERP to ICRON, that takes about 30 minutes. And then when the model is constructed for the first time and sold from scratch, it takes about 3 minutes. And due to Gurobi's warm start capabilities, re-optimization after adding a manual constraint or adjusting data is just a few seconds. And if the user has added a large number of constraints that are conflicting between each other, then the problem may become infeasible, in which case we utilize Gurobi's infeasibility analysis code, and often it finds its infeasibility explanation within about 15 seconds. And we have deployed this decision support system in 2011, and it's been in continuous use since then. And there have been a number of gains that the business has observed over time. Some of the most important ones are reduction in MRP nervousness and increase in data visibility and correctness. And once we set up this system, basically it provided a basis for other studies. And over time, we also implemented decision support systems for capable to promise and detailed scheduling for main work centers. And as a whole, the SNOP process itself has increased a lot in the effectiveness, which the senior management used to establish new ways of working among business functions. And some tangible gains, the planning technique before the project was completely based on Excels and number crunching on Excels, and it was done by planners manually. And now it's completely automated and it's based on optimization. And the planning time has been reduced from 2 days to 3 hours. Over those task of 2 days, during the duration of 2 days, the planners were only able to generate one scenario that is consistent, basically. So they could only generate one scenario after 2 days of work. But now within 3 hours, they can generate multiple scenarios. And about 30 minutes, as I explained, are spent in downloading information, then a few minutes for the first solution, and then the remaining part of the 3 hours is for doing what-if analysis, creating multiple scenarios and comparing them, etc. And then feasibility and consistency check that was manually done by planners on Excel. Now it's completely automated by the infeasibility detection algorithm. And this SNOP meeting frequency, they could only meet once a month for SNOP type of meetings. Now they can do it weekly and as needed whenever a significant change occurs in market conditions or supply structure. And planning accuracy has improved significantly. Now they can do the netting much faster, which is much faster and much more frequently, which has had a significant benefit on reducing inventory levels. And the financial benefits have been estimated to be over $1 million annually. Now, to conclude, supply chain optimization is critical to ensure supply and demand balance in any organization, and to ensure efficient utilization of resources and having cross-functional alignment, which in total has a significant impact on sustainability and profitability of the company. But to do an effective supply chain optimization, there is a need to focus on the decision processes and have increased situational awareness and visibility across the supply chain, and also be able to do rapid scenario analysis and align different business functions. And due to the reasons that I discussed, I think mathematical programming provides a very practical and flexible technique for supply chain optimization. And the visual algorithm environment that we provide, GSAMS, it actually really facilitates the usage of optimization within the decision processes in any organization. And the combination of ICRON and Gurobi enables the decision-centric optimization for supply chain.